find the final velocity, magnitude, and direction after the completely inelastic collision. So got this problem by request in class, just because it seemed like a few people still felt uncomfortable with it. So this is just a classic momentum problem. Anytime you see a collision, you know it's momentum that we're talking about. It's useful for stuff other than collisions, but most of the time in this class, momentum is used when you got two things smacked into each other. And that's exactly what we have here. We got a 25 kilogram guy going off at this angle at 8 meters per second, and we've got a 75 kilogram guy going this way. Now you notice that only the orange one has a momentum in the y direction. So before we even analyze this, we know that in the end, they're going to be moving down in some kind of way. But in terms of whether they go right or left, it's not really clear until we work out the problem. Because you got the orange guy and he's going to the right a little bit, but he's tiny, and you got the green guy going a little bit slower, but he's also big. So we don't really know yet. They're kind of fighting in terms of right and left, so we don't know how that's going to play out. So as you know, to calculate momentum, it's just going to be mass times velocity, and that's exactly what I did here. I just multiplied mass times velocity on both of these. And you end up with 200 momentum on the orange guy and 300 momentum on the green guy, so pretty close between them. The green one's very easy because it's all in the x direction. It's simply 300. You could call this negative 300 if you want. I just prefer to call it positive 300 and draw an arrow to remind me that it's going to the left, but they're both correct. For the orange one, that momentum of 200 is a momentum going in this direction. And anytime you've got something at an angle in this class, you eventually have to break it up into pieces, and that's what we're going to do. So what I've done at this point is I've broken this momentum vector into components. So now we've got the amount of the orange guy's momentum that's going to the right and the amount of the orange guy's momentum that's going down. And that's just a matter of using a little bit of trig. So for the opposite angle, you're going to run sine of 35 times the total momentum. So there's this much momentum in the y direction, and in the x direction, you just run cosine. Now keep in mind, this y momentum is going down, right? Look at your triangle over here. The momentum in the y direction is going down. So make sure that maybe you write something over here to remind yourself of it, or just look back to the picture or something like that. The momentum in the x direction is going to the right. So now that I've got the momentum broken down into components, we just got to organize it and put the problem back together again to see what we can do on this part where both of them are locked together. So we got to just find the total momentum in the x and y direction. So I've boxed the x momentums in red. You have 300 to the left from the green guy and about 164 to the right from the orange guy. So I listed both of those. You can use negatives for the stuff going to the left if you want to. I prefer to write direction. I think you're less likely to make mistakes that way. So when you combine these two, you got 300 to the left, 164 to the right. You end up with 136 to the left. So this is the total momentum in the x direction. And for the momentum in the y direction, it's easy. There was only one value. So now that I've established what the momentum is in the x direction as well as the y direction, now we just got to build a triangle to figure out what the total momentum is, this hypotenuse of the thing. Also, when you combine the x vector and the y vector, make sure that you do it correctly, head to tail. It's a really common error for me to see people doing this when they're putting these vectors together, and that's not going to give you the proper direction on your hypotenuse. You always want it to be head to tail, so where one vector ends, you draw the next one, so be very careful on that. But anyway, then you just fill in the values that you have. Pythagorean theorem to figure out the total momentum, pretty easy stuff. And you get 178 for the total momentum. So now we just have to figure out the actual velocity that we get on it. So down here in the bottom left, I worked it out. You got the total momentum, and you know momentum is just mass times velocity. We got to use the mass of both of them. So I say that the momentum equals 100, the mass of both of these times the velocity. You get 1.78 meters per second. Now all that's left is to find the angle. Okay, so all that's left is to find the angle. And in order to find the angle, don't let this trig stuff freak you out. You know that tangent of theta equals opposite divided by adjacent, right? Well, all you have to do to get this theta by itself is run inverse tan on both sides of the equation to get theta, and you get 40 degrees.